In this AstroPictionary Physics Math, we're going to go over elevator problems. We have a girl on an elevator and her mass is 50 kilograms. The elevator suddenly accelerates upward at a speed of 2 meters per second. And she feels like she gained weight for that second the elevator jerked upwards. She is standing on a scale in the elevator. When the elevator is not moving, her weight is 500 newtons. We want to find the value listed on the scale during that brief jerk upward. We're given Newton's second law. F, sum of the forces, is equal to mass times acceleration. So we want to solve this type of problem. So I'll put SOLN, solution, abbreviation for solution. So let's take a look at this. This is case 2, and we have the elevator accelerating upwards at an acceleration of 2 meters per second. Now we have to declare which way is going to be positive. You can declare up is positive, down is positive. I'm going to declare up is positive. Therefore, this way down is going to be negative. All right, so we need to find some of the forces. So here we have this girl, she's in the elevator, and she's standing on a scale. She has weight, and that weight is pulling down on her. And that weight is 500 newtons. Now she's not falling through the floor when the elevator suddenly jerks upward, so therefore the floor must be pushing back on her, equal and opposite. So I'll draw that in a different color. So we call this the normal force. And we put an arrow above it indicating normal force. Now we need to do sum of the forces, and we're going to sum the forces up in the y direction. Start with the up forces, and we have N going up, the normal force, and we have weight going down, so we subtract off the weight, and that's all we have. We have no other forces. So now we substitute this into the Newton's second law equation. So we have normal force going up minus the weight is equal to the mass times the acceleration. Now we know enough to be able to solve. Let's substitute N. We don't know N. We do know the weight. The weight is 500 newtons. And notice the negative sign is there indicating that the 500 newtons is pushing down or going down. So N with a vector above it or an arrow above it is the normal force. It's a vector. N with no arrow above it is the unit Newton. We're given a mass of 50 kilograms. And we're given an acceleration of 2 meters per second squared. So let's multiply out the right-hand side. Take the numbers first. 50 times 2 is 100. And let's take a look at the units. We got a kilogram times a meter. Both are in the numerator. Second squared is in the denominator. Kilogram meter per second squared is a Newton. And the value is positive. We still have on the left-hand side N minus 500. Now we want to get N by itself on the right-hand side, on the left-hand side. So we need to add 500 newtons to both sides of the equation. Which doesn't change the equation because we're doing the same thing to both sides of the equation. Carry my equal sign down. What we have here is minus 500 plus 500 is 0. They cancel each other out. We're left with N on the left-hand side, your normal force, and that is equal to plus 500 You're adding these two up, so you have positive 600. 600 newtons. And then let's put our arrow in to make sure. So I had drawn the normal force up, and sure enough, up is positive. So that's our value. So for that brief instant of time that the elevator jerked upwards at a speed of 2 meters per second, the scale, remember she's standing on the scale is going to push up on her, and she is going to pull down on the scale. She feels heavier. She's going to push down on that scale, and the normal force is going to oppose it at a value of 600 newtons. So since the normal force is going up, then the weight must be going down. We have to say the weight that is read on the scale, we have to answer the question. The weight on the scale is going to be negative 600 newtons. Remember, we have to put the weight is going down. Weight doesn't go up. So we answered the question here, and I'm going to double box this one. So we know that that one's the correct one. Let's make sure we answered the question. What's the value listed on the scale? So it's not asking for the normal force, it's asking for the weight on the scale. So the normal force is what's going up, but the weight on the scale is what's going down. So for that brief instant in time, as the elevator accelerates upwards, she has a slightly more massive weight. Remember, she weighs only 500 newtons normal life, but she feels like she weighs 600 newtons down.